Hey mathematicians, let's do your homework. Okay, so our first one is looking for a statement that best describes the data. So a true statement about this data. Let me move the screen so that we can see the whole data set. The data is skewed to the left. Skewed to the left looks like most of your data is on the right and there's a little bit off to the left. That is not what ours looks like. Data is skewed to the right. Does it have a tail that goes to the right? Yeah, this one does. Okay, this is a possibility. The data has no gaps. Gaps are empty spaces. I see a big one right there. That's a gap. So that is not true. The data has no outliers. Well, by definition, if you have a gap, it means you got something that's pretty far away from everything else. That is an outlier. So it is not true that there are no outliers. Our answer is B. Here is a dot plot talking about chocolates sold. 25% of students sold 30 or fewer. If I stop reading at 25% of students sold 30, that means that I would be looking at the number that is above 30. Or fewer, fewer means smaller. So if you phrase it like this means that you are including 30 in the part that we're talking about here. So to make a percent, because I've given you the percent, we're trying to see if it's equivalent. To make a percent, you need a part that we're talking about, the part that happened to sell 30 or fewer chocolates, out of the total or the whole number of kids who sold chocolates, or number of chocolates that were sold. So in my part, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Out of 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25 chocolates. Now, in order to make a percent, percents are always out of 100. So you need to scale this up out of 100 to see, oh, does 10 times 4 make 25? I don't think so. This is 40% right here. So the first one is not true. So you're going through to calculate your percent. So you're counting the number of boxes, or sorry, not boxes, dots that are included in those descriptions. And then you're making them out of 25. Multiply it times 4 because 25 times 4 is 100. And that will give you the percentage. This last one, though, D, does not say percentage. It says median. That means the middle dot. So if you have a middle dot, we're talking about not this dot, and not this dot, not this dot, and not this dot, not this dot, and not this dot. So you literally have to cross them all off and find the middle, and then find the middle of the first half and the middle of the second half and subtract to find the interquartile range. Number 3, we are not looking for interquartile range, we're just looking for regular range, which is the maximum minus the minimum. Maximum means the biggest number. Mini, if it's mini, it's really tiny. Biggest number minus the smallest number. Find that answer to subtraction problem, and that is your range. Ooh, all right, here we go. Bob conducted a survey of people outside a grocery store. A survey is when you ask people questions. And his question was, what type of chips do you like? He gave them 3 choices, and I can tell what the 3 choices are by looking at my key. Corn chips, potato chips, and kale chips. Y'all, as much as I love kale, and it's a great vegetable, when I want chips, I want potato chips. So my choice would have been potato chips. Looking at this percentage bar graph, the really dark gray or the black, however you see it, however good the printer was when we printed your homework, is kale. So here I can see that is 100 to 90, that's 10, to 80, that's 20, or 100 minus 80 is 20. This is 20% of the people said, I like kale chips best. It's the next easiest to look at corn. Corn goes from 0 to 30, so that is 30%. It's a little bit harder to find the middle section, so what you do is you take the top percentage and the bottom percentage, so 80 and 30, and then you subtract them to find out how much space is between them. 80 minus 30 is 50%. Quick check, 20 plus 50 is 70, plus 30 is 100%. Okay, we represented all of our data. So we're trying to see which of these tables would match this graph. Personally, what I want to do is rank them. Which percentage is the biggest? Is it corn, which is the lightest gray? Is it potatoes, which is the middle gray? Or is it kale, which is the really dark gray or black? The biggest percentage is 50, so in your tables, you should be finding the biggest number as the potato number. In part A, the biggest number is kale, which is not potato chips. The biggest number of people did not vote for kale. In C, the biggest number is corn, which is untrue. Corn was the middle option, not the most popular, not the least popular. In B, 25 is the biggest number. Potato, yep. Most people liked potato. All the other numbers are smaller. Same with D, potato. Best option. We are just choosing between B and D. Now D, I notice, has 6 and 6. Those are the same number. That could only happen if they came from the same percentage. Oopsie. Lost my screen there. Is this percentage the same as this one? Nope, which means that they should have different numbers, not the same number. So by process of elimination, our answer must be B. Last problem. Shoe sizes in Mr. Larson's class. We're looking for true statements. The median means middle number. Oh no, I just lied to you. I didn't read the problem. That's bad job, Ms. Douglas. I'm modeling what you shouldn't do. Which of the following statements cannot be justified? We're looking for false statements. If you look for true, you're going to definitely get the wrong answer. The median, the middle number is 7. All right, this is my median. It's 7. Yep. And the interquartile range, the IQR, is 1.5. All right, IQR comes from quartile 3 minus quartile 1. Here's my quartile 3. Here's my quartile 1. This one's my minimum. This one's my maximum. Quartile 3 is between 7 and 8. That's 7.5. Minus 6. Does that equal 1.5? Why, yes, it does. So you're going through each of these and you're checking to see if they're true. If they're true, they're not our answer. 50% of the class's shoe sizes are between 7 and 10. Each section on a box and whisker plot represents 25% of the data, even if they look like they're different sizes. So this is 25%, this is 25%, this is 25%, and this last section is 25%. They are quartiles, which means you literally cut them into quarters or 4 sections. Just because one section has a bigger spread doesn't mean there are more numbers in that section. So, between 7 and 10. Here's 7 all the way to 10. Does that represent 50% of your data? You decide. So, we're checking range, we're checking mode, we're checking smallest, which would be minimum. You're looking for the one that is either blatantly wrong or that you cannot prove from this graph, because the question is which cannot be justified, which cannot be proved based on this picture. Maybe if I had the full list of data that made this picture, I could prove or disprove something else. But if you do not have that information on the picture, then it is not considered the correct answer. Or it would be the correct answer because it would not be something you could prove from your graph. It's been a long week, and we're only at Wednesday. Finish up your homework. I will see you tomorrow, which is kind of like a fake Friday because we do not have school real Friday. So, last day tomorrow. We can do it.